Good morning, Alex.
Good morning, Michael. Hello. Hi. How's it going? How was your weekend?
It was good. It was good. I visited my dad yesterday and
Mhm.
watched Dark on Netflix with my youngest daughter.
Oh,
Both of
nice.
which are actually hints to our topic today. um,
Yeah.
Otherwise, I was a little bit outside, but not too much because of the storm. I don't know how the storm was for you in Munich, but it was probably worse in northern Germany. That
Seems
really
to be,
wreaked havoc.
yeah, it seems to be that way. It was okay. I mean, it rattled around in the night, so it was you heard that was something was going on, but it was not, no trees on the streets and stuff like that. So definitely not as heavy.
Yeah.
Yeah.
And I got a new camera, so let's see how this goes with the new camera and kind of recording and everything. So let's see. And the
Yeah.
microphone should be better now, so I moved it closer. So let's see how that goes.
No, sound is good. I hear nothing of that sort. If you have any
Okay.
comments in chat, let us know. But I think it
Yeah.
looks good and sounds good as well. Yeah, we can probably dive in right away. If you're watching this live, let us know where you're watching this, when you're watching this. What's your day look like? Is this your lunch break or your breakfast session?
Breakfast
Yeah,
or dinner.
or dinner, maybe
Or
even
post
dinner. Yeah,
dinner, right? Or,
yeah,
or late night show. A video
exactly.
late night show.
Yeah, yeah.
Yep.
Maybe a lullaby. No, hopefully not.
Exactly.
Yeah, let me switch on here to share this, and then let's change this a little bit. Here we go. And move this out of the way. All right. Okay, so here we go. Just before we dive in, one other thing I wanted to mention today is the Graph Connect call for papers is open. So we announced this last week, I think, and we have a link. I will post a link in chat in a second. But Graph Connect used to be our yearly community event where everybody came together um, in one place. Now has been on hiatus basically for a little bit due to obvious reasons, and it's going to be back this year in June. This year, 6th to 8th of June in Austin, Texas. So we are looking forward to that. And yeah, if you are interested in presenting, no matter what topic, there's we have a huge range of topics we can do. And if you are expert on some of these, let us know. Fill in the type form, and we'll get back to you. But yeah, if you
Yeah.
yeah, yeah.
Really looking forward to be there and see you all. So if you can make it, that would be really amazing. And submit your sessions, no matter if it's a lightning talk or a regular session or workshop.
Mhm.
Feel free to pick whatever. You can also say this is an alternative format that I can do. And yeah, we are really interested in sessions. So please share and let us know what you would like to talk about, even if it's just something that you haven't built yourself but used, or a cool library or tool that you found or something like that. Everything is welcome as such.
Yep, perfect. All right. Well, with that, let's go into today's session. Hands on with Neo4j AuraDB free. The plan is as follows. I'll give a quick recap of what Neo4j AuraDB free is, and then we pick a data set and we look at it. If you have a data set you'd like us to explore, get in touch with us. On Twitter, on YouTube. You can type it here in the chat below, in the comments, on email, on Discord, obviously. Any form is welcome. Let us know. We have picked the data set, so we will have something to talk about today. We develop a few questions. What kind of queries would we like to ask of that data set? What would be interesting for us to hear? Then we will kind of determine that data model loading query and then dive in and check it out in Neo4j. So what's the deal with AuraDB free? So it's a free version of Neo4j AuraDB, which is the graph database as a service offering from Neo4j. It is very similar to the sandbox you might have already been in touch with before, but the difference is this is with you forever, whereas the sandbox was a limited offer which you had to renew, and then it would cease to be available for you, and then you had to start a new one. With AuraDB free, you have one available for you infinitely. It's limited to 50,000 nodes and 175,000 relationships, so that's a little bit of a limitation there. But I guess for experiments and for testing purposes, this should be way beyond what you will need. And you have obviously access of Neo4j Browser, which is our query tool. You will see also in a second, and also Neo4j Bloom, which is our visualization platform. Do you want to say anything, Michael?
No, exactly. So, and we'll see it in a second what this looks like and how you can use it and such.
Yep. Exactly. And then also, if you're wondering where you get this, also links coming in chat in a second to the landing page for AuraDB free. And so what are we going to do today? It's family tree genealogy. I have just to check this out, right? I mean, if you type this into any Google, Bing, whatever, it doesn't matter. What do you get is like, if you type in genealogy, is all these, trees, family trees. Here is all these are word trees here a little bit, but then here again, this is like a tree of people. This is another tree. And these are not very listy things, so this is not something you would like to do in a list, I think, and hence I think a graph is probably a good, Oh, you also have the same pictures. They're very funny. All right. Well then, switching over to Michael's screen. It's the same picture almost.
No, almost. Yeah, I also pulled up a few examples here. So a royal family tree is very deep and old. There's even a demo file for that. Then we have things like the House of Black from Harry Potter, where Harry discovered the family tree in one of the rooms of Sirius's house, if you remember. Another one that's quite well known is Game of Thrones, all the different families and who loves, kills, or marries whom or fights whom, right? So that's also a very typical one. And then, as I just mentioned, I've watched Dark with my daughter, and this looks like this. So I only show it really quickly so that we don't spoil too much. So it's also a very complex family tree there, and even graphs, right? So there. As you see here in Game of Thrones, it's not just a tree, but there are also connections across lines as well, right? And then if you add additional data, like for instance, places where people have been born, have married, or have died, or lived, or so, then this becomes even more of a graph, or even a knowledge graph of some kind, right? So if you add family information to it and other things as well, right? So we want to look at this today, and actually it started. I know that our colleague Rick did a blog post in 2014 already. So it's from January 2014. So that's more than 8 years ago. Where he basically, after the holidays, he found some ancestry data going back to the 1400s or something like that. So really, really long way back. And he basically used a tool called Grams, this one here, which is an application that you can install and load these ancestry files into, and you can export them as CSV. And then he talks a little bit about how he modeled the data and how he imported it into Neo4j, which was quite interesting. So that was a very old, basically example of that. But then a week or two ago, another colleague of ours asked me if I could help him importing some of his ancestry data in Switzerland. And so I looked at it with him, and the file format is actually very textual. So we can actually have a look at this. So for instance, if we look at this file format, I hope you can see this. So it's very textual, right? So it looks like a COBOL file or something like that, where you have really like each attribute is on a single line, and then you have like it follows like this, right? So and then you have like all these things following one another, and it's would be really hard to work with, right? So I mean, there are many tools online and offline that work with this kind of data. I think there are millions of getcom files from all kinds of families and people that are eager to collect this kind of information. But it's not really easy to work with as such, right? And
No,
so the
that's
initial,
very difficult
yeah,
to.
yeah, it's
It's
I mean, if
yeah.
you Google for like COBOL code or something like that, and you look at images, let's see, then you see that it also looks kind of similar in this kind of very textual format, right? So so I think that's like in data interchange format. It's already quite old, the getcom file. And so we looked at a bunch of tools. So first I found this Go tool here, written in Go, that allows a kind of query language on top of the files, where you can basically, where was this? I created actually an issue here with an example. So you're basically similar to JQ. So we used JQ sometimes to handle JSON data in the past. And you see it looks a little bit similar, right? So you use the file, you say, I want to format it as CSV, and then you say dot individuals, and you want to get a name, the born date, died date, and so on. So which works quite well in general, but then I had trouble getting family information out of it, right? So I got basically parents and parent names and a family ID, but I couldn't figure out the syntax for getting actually the IDs of the parents. And so I tried to figure it out, but I wasn't able to. So I left this and thought, oh, there's a Python library for everything, right? So and I just looked at Python libraries for getcom files, and there is this. Where's it actually? Oh, here. There's this Python library for getcom that we're gonna use today. But before we dive into this, let's take a quick detour and look at our Aura instances. So where's Neo4j Aura? Here. So first of all, we want to create an AuraDB free instance. So we just go to AuraDB free, or go to AuraDB and say create a database. And then you say I want to have a free database. We give it a name, for instance. Let's say ancestry or something like that. Ancestry. I pick it in Belgium and I create an empty database here. Right. So I do this. I need to copy the password with this copy icon here and tell the database I stored it. It takes 2 to 3 minutes for the database to be created. So I'll just put this password here into my console. I'll delete the database afterwards. Anyway, but store it in a safe place. Otherwise, you will lose
you need that
access
password, yes.
to your database.
Yeah.
Exactly. And you would have to ask support. Or you can also change it afterwards in the database to something that you can remember, or your password manager can remember as well. Right?
Yeah.
So we'll just leave this open for the time being, and then we'll continue over here with the Python files. So I showed you the getcom files, what they look like, and they are not so easy to handle, right? So, but fortunately, in the Python library, there's actually a code example, which I basically just took and copied, and says, take a file, or get a parser, parse the file. I hope this is readable. Parse the file.
It's readable, yes.
Get the root elements of this file, and then for every element that's an individual element, which is kind of a person, then we can do things on that person, right? So it just checks if this element is an instance of an individual element, then you can do stuff like getting first and last name and other things, right? So there's also documentation here what you can get from a person. So for instance, here, if you have something like, there's the person down here, you can say, is it get a name, is this person deceased, get the birth data, get a gender, burial data, census data, occupation, and so on. So there's a lot of stuff that you can get from a person itself, which we'll use. And the other thing that we'll use is kind of accessing the parents. So because you want to create this family tree, this tree structure, we also need the parents. So that's not on the individual person, but you would ask the parser basically get parents, and you have to pass in the person as a parameter, and then you get a list of the parents basically, and such. as people again, and then you can work with this together.
And then it starts over, or how does this work then?
No, I showed in code in a second what it looks like. So I basically wrote a really tiny and ugly Python script. This one here, I put it also in GitHub, so I can also paste the. I didn't start restream actually. Let me do this real quick. The restream app. So I hope this comes through. Yeah. So I put the file on GitHub, so you can access it there, and it's basically what you just saw: getting the parser, creating the parser, parsing the file, getting the root element, and if this is an individual element, we get name, birth year, death year, gender, and pointer is an ID. So that's kind of the most important thing. So I have this row of first name, last name, birth year, death year, gender, and ID. And then I asked the parser actually to get me the parents for this person, basically. So I have here an array with the parents as such. And then I just look into this array and see when I find a person with female and male, I say I add this as mother and father to the list. And this could be empty as well,
okay.
so then it wouldn't exist as such.
Yeah.
Right. And then I just turned this data into a very simple CSV. So I didn't bother with data frames or anything like that. I just output a comma-separated list here manually.
You make it into a CSV. Okay.
Right, so I just have this list of data here, and then I just say join this with commas, and then print it out, basically. So you pass in the file name, and you get an CSV out. So if I run this on my example dataset here on the royals, for instance, then I can say get com to CSV, and for instance royal 95, and if I pipe this to less, then I would get this output here: first name, last name, birth, then gender, ID, mother, father, and here Victoria, Hanover is the last name, born, died, female. This is the ID of the person itself. Victoria, first probably, or no, the first is the and then mother ID and father ID, basically.
I see. Okay.
So, and we don't need to provide more information for mother and father because they should be in the data as well, right? So from that perspective,
that makes sense.
we just point to the ID, and if they're not in data, then at least we have a pointer there, and we could enrich it later on if we wanted to, right? So from some other place as well. So I didn't extract more data, but you get the idea, right? So it's just then adding something like get your
exactly for the example. This is perfect.
Get occupation or get census data. You would just add this to this.
Occupation king, occupation queen.
Yeah, actually, I wonder what it outputs as occupation. Should we try to see what comes out of that? Let's try this.
Rule.
So let's say we add occupation after the ID, and we just need to check out what the occupation is. A string. Okay, cool. That's easy. So just after the ID here at the end, we just add e.get occupation, and then we already added it here, and so it should automatically just put the stuff together. So if you run this again, then occupation empty. Okay, there seems to be no occupation. Sometimes a -1. Okay, no real occupation anywhere here.
Done.
I'm not sure. I also have a precedence file here. I'll show you where I got these example files from. Home downloads, precedence, press 2020. And they have, here's an occupation, US president number such and such.
Yeah.
Right. So you have at least one of them has an occupation.
Yeah,
no, here there's another one.
Democratic, a few.
Democratic,
but it's not, maybe it's not the. Yeah.
So it's not too much in there.
Not
right?
too much
so,
in there. Yeah.
Okay, so I'll remove it again, and then we don't bother with the occupation. But you can imagine if you have a file that's better maintained, basically, or where there's more data in there, then you can actually use this to make more sense of things. Similarly, I didn't extract marriages or families or other things, so there's much more in the data if it's maintained, right? So so from that perspective, there's more to be done.
Yeah, exactly.
Right. Okay, that gets us, so you, as you can see, right, so there are census data of additional information with where did they live, for instance, where were they buried, or where were they born. If you get, not say get birth here, but if you say get birth data, then you get like a date and a place, basically, right? And a list of sources, which can also be interesting if you want to have, especially for historic records, where did this information come from, right? So you also get a list of sources, which can be really interesting from an investigative perspective as well, right? Because you want to have like confidence in the sources as well, or you want to cross-check the sources yourself, or things like that, right? So which is really interesting.
Yeah.
Okay, so there's a lot of stuff here, and then for the individual things, there's also more basically that you can. There's also like a generic like value thing that where people can just store arbitrary information in these files as well. So there's much more to be had from that as well. Okay, and I mentioned that there are some example files. So when I was just searching for Godcom data, I found this page, which looks a little bit from the 90s, but doesn't matter. It has these kind of files with the royals that I showed you, Shakespeare, Bronte, and presidents, right? And I just downloaded them here, and these are the files that I just showed you. So if you need something to use, because I can't share my colleagues' data, of course, and or if you have your own, then you can use that as well.
Yeah.
All right. Okay, and that gets us actually to getting this data into Neo4j. So if we were to use our president data, for instance, and put this into presidents.csv, we just pipe it into this file, and then we see this has 2,300 lines, and we can also look at it. And you see like these are like different presidents of the US and their spouses and kids and stuff like that, right? So that's our CSV. And now we can actually use the data importer, the Neo4j data importer here, which is really useful. I'll also paste it into Restream, into the chat. That allows us to simply take and model and load data into Neo4j. So we don't need to worry about kind of writing all the things ourselves. So I just go to a getcom folder where I just created the CSV file for the precedents, open that, and I see here my content of the CSV. And this is actually quite a simple data model, unlike the others that we usually had. We just have a person node, right? Because it's about people. And we can click on this person node and say we want to map this file to our person node, and we want to map the properties from this file. And basically we can select them all except for mother and father. So we don't need to store that on the person because that's relationships, right? So we have the ID, gender, birth and death, and first name and last name, right? So some will have incorrect birth and death information or missing, but that's just
how it is.
data, right? So, and we can actually convert birth and death year into integers. So we can do like comparisons and things like that. And what's important down here, we need to select an ID for this person, so it gets the blue check mark here, right? And then we have our mother and father left. So here on the left side, you also see what has been not mapped yet in a CSV file. And so we can just, on this halo that pops up here on the rim, we can just pull out a relationship. And what we can do is we just point it back to the person and get a self relationship, basically. So we let it just drop on the person again, we get a self relationship. We call this mother. Select our file again and map from person ID to mother. Right, so it's pretty straightforward, and then we do the same again, and this is our father. Father. and exactly the same from person ID. Not exactly the same, but equivalent from person to father, basically, right? So that's our model now. And what we can do now is we can import this data. But the other thing that I wanted to show you is that you can also save this model with the CSV and the mapping into a zip file. So I can just put this into an precedence data importer .zip, right?
Yeah.
And imagine
It's
we
easy.
had just started out with this and it was all empty. I could just say import zip and go to my downloads folder, click on this, and it would be back where I started. Right. So I have the CSV and the mapping as well.
Could we model siblings with this data because we have?
We can do it in a graph, not with the CSV itself, because we don't have the data in the CSV, right? So we can do it in a graph. So basically, people that share mothers and fathers, basically,
Exactly, yes.
siblings or half siblings, basically. And but let's do this perhaps as post-processing of the data in the graph then later. What we could do if we had in the Python script we had gotten there's also something like get family here. Let's see, sibling family. And he gives there are family elements, and then you get a list of family element, and then you have to get say, is this a parent, is this a child, and in this list, and then you could go over the elements of this family, and say, okay, if this is an parent, then I'll add it as a parent to the CSV. If this is a child, then I add it as a sibling, kind of, right? Or then I would probably do an one area for sisters and one for brothers or so.
Yeah.
So you can create relationships accordingly. But that's also possible, right? You can get families from the parser for this element. And a person can be in multiple families, right? As you all know, many people are living in patchwork families where you have previous relationships, half siblings, and all kinds of interesting combinations. So you actually get a list of families basically, and then for each family, you can then ask, okay, who are the parents, who are the siblings, and who are the other members basically. So it gets already quite complicated in CSV to handle that
Yes.
as such. So it's much easier in the graph. And in the graph, we don't even need to do this because we can actually just go and look at the graph data and pull it from there. So we can do this afterwards, I think.
Yep.
But good question. So it's possible in a Python library here, of course, but in the CSV, it would be harder to handle because you would have for each family, you would have to put in, okay, is this kind of a sibling from this family or from this family and so on. So that's kind of an interesting exercise that we can do. Okay, now we have our data importer, and then let's check on Aura, which is actually here. So we created our database, we stored our password, I'll copy it just again really quickly. And we have here our ancestry database. And I can open this with Neo4j browser. It's running now. I can open this with Neo4j browser. And if I open this with Neo4j browser, I paste in my password, then it connects and it should be empty. So there's nothing in there. It's an empty database. Right. So, and now with data importer, we can import this data into data importer. So we can click on run import here, paste our password that I have here and our connection information, which is directly here with the database. So I copy this connection information as well and paste this in here. And if I run this, then it takes just a few seconds, and then you see the progress here, and then it's done. So it takes 3 seconds to import the data, and it creates these. Yeah, I mean, it's not a lot of data.
Yeah, exactly, but still.
100 kilobytes, but it creates 2,300 nodes, right? So it's not a tiny. It's a small graph, but not like a 3-node graph or so, right? So it's for a human. Imagine you had to draw a graph with 2,300 nodes. That would be of a weekend exercise.
Sounds like more like a punishment than anything else.
Yeah, exactly. Your job is, is to write down the family. And don't make mistakes, because if you make mistakes, you have to start again. Exactly. So you see here how much data it created, also how many properties it created. So you see that it's for each node it created like 5 or so properties, or 6, probably 6. And then we can also look at the queries that created the constraint of this node, which is kind of an ID constraint, and also how the actual node was created. So for each record that came from the CSV, it created a node based on the ID, and then set first, last name, birth year, death year, and gender. And you see, because we said birth and death are meant to be integers, it converted them here as well to integers, right? And then for the relationships, it created the relationships here to mothers and fathers, basically finding the person and the mother, and then created the relationship to each of them, right? And it's 1,200 relationships to mothers and 1,100 relationships to fathers. So it's probably, if it didn't find the data, the father information, then it didn't create a relationship, right? So if,
we
if that was
don't
missing,
know, maybe,
right? So if there's no entry in the CSV for that person, then it would not create a parent relationship to that. Okay, and that's about it. And what we can do now is look at our database here, this one. And now it should not be empty anymore, right? So we see 2,300 people in here and 2,400 relationships. So there should be actually twice as many relationships than people, but I think that's kind of just the missing data. That's where the people are not in the data, right? So, and if you just click on one the relationships here, we can see some information. We can show what we want to see in terms of labels here in a graph, and we could say, for instance, the last name or the first name as such. Right. So both of which are not so helpful as such, right? So we want to have the full name. That could be our first post-processing actually, where we say, okay, can we create a full name basically of a person, right? So we find just every person and create an set p.name equals p.first plus space plus p.last. Right. So we run this, and it now set 2,300 properties. And if we change the visualization here, it should say, let's run this again. It should say name. And now we have the full name for everyone in our graph visualized.
Yeah, that's helpful.
And you already see that this is kind of, it starts forming this kind of tree structure, right? So where you have a node in the center, and then things are hanging from that node, right? So as you know, in family trees, it actually goes broader to the top because you have the parents and the grandparents and the great-grandparents as such. So it's actually like an inverse tree almost. Like if this is the child, then you have here one parent, and from this other parents and so on, right? So it gets basically broader from here.
Yeah, apparently this person has 2 fathers and 1 mother. So
no, actually, I think this is going in the other direction. If you look at, can you see the arrow tips here?
No, it's a little bit far away.
Yeah, so 1 second. So you have basically 1 father, one mother, and the other thing is he's a father of someone else.
I see.
And then we have the mother of this other person. So there are like 2 subtrees basically in here as well.
Yeah.
Right? Okay, that's something that we can do quite easily. The other thing that we can do is, let's see, perhaps you can do the siblings thing or the families thing, right? So a person with their parents, basically, we could actually merge them to a family, right? So we could say, find me a person. So let's see, find me a person. And then we want to find a person and their parents, right? So this person has a father. Perhaps it has a father. So we probably want to do this as an optional match. So we find our person. Let's call this P, and it's more obvious. And so if you do just a match to father, then if it doesn't find a father, then we don't get anything back here, right? So so we actually want to have an optional match. And the same for the mother. So if the mother is not there, this would be not existing here. And so that would be our 3 people, or 1 and potentially parents, right?
Yep.
So we could, from this, we could actually create a family. And that's now an interesting question, right? So we could say the family is just the core family, basically, which is kind of just related to this person, to say so, or this these parents as such, right? Or it could be the family with this last name also, right? So like the larger ancestral family.
I know what you mean. Yeah, so including grandparents and stuff like that. Yeah.
Yeah. So if you do the ancestral family, we would just globally merge the family name based on the person's name, for instance, right, or the father's name, or whatever we want to use. But let's see. I mean, in Western civilization, very frequently people pick the. Actually, we want to say this is the mother. Yeah. Right. So let's say the person's last name. It might not be 100% correct, but you get the idea, right? And then this would be like the global family. And then we would actually create from all 3 people a relationship to that family as such, right? And so we could do this individually, where we say merge this person to in family or off family, or just family. Actually, we can do just family F, right? So we can create this family, connect this person to it.
Not that I might be confused with father, no? Above.
Oh yeah, sorry, fam. Right, this is my fam. And then we need to do the same for mother and father as well, right? The little bit of difficulty is, so that if you do this just as such, it should probably complain that some of these nodes might be null, father, mother, right? So because some fathers and mothers could be null, so they might not exist here. So if you just run this like this, let's see if it complains. Yeah, so this node F is missing here, the father is missing, and then you can, it's not working. So what we could do here instead is actually, we can put all 3 together into a list, right? So we take our family, and we take our list of person, mother, and father as people, right? And then we would just say, we can filter this list and say every person in this list that's not null, that kind of where not X is null. Right, so we don't want to have, so if they can't be found, the father and mother or the person, then they would be null, this element. And we just want to have the remaining people that are not null, right? That's our people, and then we just go over these over this list, unwind people as P, and then we just do this once. So basically, we have our family and our people that are not null, so that have been found. And then we take each person individually. I can also say person here, for instance, person, and create the relationship to the family. So that's one way of doing this as such. And now it should actually work. And created 873 families, which are the global families, basically. So we should have something like the Lincolns and the Grishams and so on, and Adams family, and so on, right? So Patton, Rodham, Clinton family, Hillary, and right. So, and we have probably the Kennedy family is probably more massive here, right? So where n.name contains Kennedy. So this is the Kennedy family, and then we can see.
Oh yeah.
That's like
a few people,
American royals for you, right?
Yeah.
So it's kind of, so of course it's not 100% correct because last names can differ. Sorry, last names could be duplicate. They're not necessarily unique. So if you have someone who's called Smith or Miller, then you most likely you would have created families that are actually
Yeah,
not correct, right?
Yeah.
So you would probably do a little bit more. Either you get the data from the getcom file itself, where it says family, and then give me the family, or there's also something called the ancestors. So you can also get all the ancestors of a person and pull them together into a family. But that's kind of a quick thing. The other option is that we could have, instead of creating this family globally, we could have tied it to one of these people, right? So where we say we create this family only in the context of this person, to say so, right? So where we say this family is not global, but we create this family in the context of this person or these parents, for instance, right? So we could say we create the family in the context of the father, for instance, right? So it belongs basically to the father or something like that, right? So then it would be not a global family with this last name, but only tied to this core family, basically, of a father, mother, and person, basically.
Children, yeah.
And the children, right? So then this should come together. It's probably even better to tie it to the mother if it's the maternal children that count, right? It depends a little bit of what you want to do here, as such, right? So we could also do this. So let's try this. If we call this core family instead of family, then we can actually try this and see what it looks like, right? So we tied it now to the mother if it's there. We can also do an, let's see, with pfm, comma, and then we can coalesce. And we can put all three together, pfm as member or so. So if either of them is null, it would just take the next in the list. So if the father's null, it takes the mother. If the mother's null, then it takes the person itself, right? So that's kind of our member. And then we tie this to the member, whoever that is, as a core family, right? And then we can actually set this not to p.name, but to member.name, last name. Right. So this would give us a different set of families. So now we get more. We get 1,400 families because we have more core families than real families. So you also see there should be duplicate names in here. Here, for instance, right, Blythe is a duplicate name. So there are two core families. With the same
that's different
name.
ages probably.
Different families, but they're connected, right? So because if you're a child in one family, then you're basically a parent in the other family, for instance, right? So we could also have, if we change this with the family creation, we could have also said, okay, we don't create this just as a core family, but we say something like, I don't know, husband, wife, or something like that, or male parent, female parent in this family, and child. We could have also done something like this, where we basically create relationships based on their role in the family as well.
Yeah.
But that's something that we can still set on these relationships, where we say, okay, in this core family, if someone has a parent relationship or a mother-father relationship outgoing, then that's a child, and otherwise it's a parent. So that's actually something fun that we can do, where we say we match our core families, and we have people here, relationship, person. So that's our people here. And then we can say if this person, let's say, where exists person, this person is a or has a mother or father to someone else in the core family, father, parent, which is then also connected to the core family, right? Then this is the child in this relationship, right?
Mm-hmm.
Set rel dot or rel role is child, right? So a person who has a mother and father, which is a parent in this family, so that's a child. And if we have a person who has a mother or father relationship to a child, basically. So if this person has a mother or father relationship in the other direction, right? So from someone else, it points being a mother or father, then we can say a parent, for instance, here, right?
Mm-hmm.
And now when you look at our core families and expand them, we have here our core family relationship, but we could also now say, we can now also say this core family, we want to actually show the role on this. And so you see that now two people have a parent role on this, and one person has a child role on this, right? And if you take another one, then here is nothing because there's no other. So here, for instance, we have another parent-child parent as well. And similarly, we can also create the siblings, where we say if someone shares a mother or father as such. So if you say let's see, if you have a person, I just need to look at the time because I want to show some other stuff as well. So we have a person who has a parent, like a mother or father, parent, P, right? And then we find other people where siblings that have the same mother and father, basically, as well, right? Where that's not the same person, right? So it's not our person that we looked at, but it's someone else who has the same mothers and fathers than our person. Then we can create a sibling relationship between the two. You can just say P is a sibling of sib. And you see that it can leave off and merge the arrow direction. So if this relationship already exists in either direction, it will not create it. But if it doesn't exist, then it will create it within a relationship, basically, with a direction between the two. So it will not create two sibling relationships between two siblings, but only one. Right? So now we see, if I run this, I don't know how many sibling relationships it creates. Let's see.
A lot.
It seems like a lot. Should have probably tested this before.
It's like a
but let's see. So it could also be that it runs into the memory.
Did we check that this is unique? No.
Okay. Yeah, we should have probably done a distinct in between. But it now finished, and we have 4,400 sibling relationships. And now we see. You can configure if it should connect all the nodes or if it should just show the relationship that you actually returned. So we see now there are siblings in the Green family. Cassidy family has siblings. And you also see that there are siblings with different last names as well, right? So they are probably they share a parent, basically, right? And now we could say, okay, if they share,
change their name because they
change their name. That's also an option, right? So either they have share one parent, only one parent, then we could even say, okay, did they have two parents or did they have one parent together? You could set this also as half siblings, or if they change the name, that's also, of course, you're right, right? So that's how we can now create a sibling graph as well in this data. And so starting from the really simple, just person with mother and father, we now have families and core families and siblings, and so we extended the data quite a lot as such. So we have
relatively easy with a few queries in Neo4j,
Yeah.
versus the other,
Exactly.
when coming from a CSV file.
Yeah, exactly. So imagine you have to do all this in the CSV also. That's kind of a little bit fiddly. And so let me actually download this so we can then do the blog post later. Ancestry cipher. .cipher. So we can actually, if you have done something in browser, you can just type :history. You see all the history. You can rerun the stuff, but you can also download it as text file, which is really useful for keeping stuff around. Or you can save it as favorites for your database. But then it's tied to this browser URL. So the same browser URL shares the favorites here. Cool. So that's what I wanted to show. The other thing that I wanted to show is Neo4j Bloom real quick. So we have browser is our kind of developer or like workbench kind of type tool where you type cipher statements and you run them, get the results. So it's more for people that want to learn or know cipher already. And Bloom, on the other hand, is something for everyone who's, which just reminds me of something. I want to probably create an index on person name. What? Okay. Because Bloom can use these indexes to search more quickly for people by name. Okay, so what we can do now is we can look at just our people. So person, for instance. In Bloom, I just type it in and get these kind of graph patterns. And then I can run this and then it gets me the data. So it fetches now all the data and I get probably 10,000 or 1,000 rows back. And you see that it's this is a lot. And we should probably be able to style this based on name. Yep. So I'm not sure. So it should actually show if we zoom in. Yeah. Here's the people and the names. We didn't. It pulls all the relationships, right? It didn't limit them. So we see siblings and mothers and fathers and so on. We can also clear the scene here and just pull person. So that's kind of a lot of people, right? And then we can select them all and just expand along the parent relationships. So we can just say, I want to have the parent relationships to fathers and mothers, and then do the other one. Expand. Where did expand go? Probably didn't. Mother. So, and this is kind of now our family tree data. So in Bloom, you can also have a hierarchical layout. I'm not sure at this volume what it looks like. Actually, it's not too bad, actually. As you can see here, you see these kind of trees of people having parents, basically, right? So that's actually quite nice.
Quite nice, yeah. Almost out of the box, like a family tree already.
Exactly, right? So, and then you can see if you scroll in a little bit, then you see the names. The next Bloom version, these names will actually pop up earlier, so it's actually quite nice. So for less data, it's also formats nice. So you can also flip this around, then it's kind of vertical. Right.
Ooh, yeah.
Or you can rotate it, actually.
You can rotate it, yeah.
Nice. But what you can also do, if I clear the scene here again, you can also say, I want to have a concrete person. So I just type in the name of the person and it knows, because it has the index, it just looks in the index and sees, oh, there's a person with Abraham Lincoln, right? So, and then I can just click on that. So for me, if I don't know cipher at all, then this becomes really easy to interact with, right? So, and there are 2 Abraham Lincolns for whatever reason. And now we can expand, for instance, all family relationships. For instance, we can go to family. So it has a Lincoln family, and now we can expand the Lincoln family and have, let's switch back to the, so we have like all these people in the Lincoln family, right? And it's a little bit unfortunate that Hamilton never became president, because that's why he's not in the data. But you can imagine if we use George Washington here, and come on, and expand from him. Let's see, for instance, his family. Okay, there's not too much. He's only by himself. And Jefferson, Thomas Jefferson.
I think you need
So we
to
could
expand
actually-
family also. Or
Yeah, good point. So we should also expand the family. Expand. Oh yeah. So there's more George Washington family in here, right? So, and then we have Thomas Jefferson as well, and then we could basically go from Jefferson to his family, and then we could actually recreate like the cast of Hamilton, if you remember our Hamilton episode, and some others, right? So Adams and others, right? So, but unfortunately, Hamilton himself would probably not be in here, right? Because he's never made it to be president, if you
Not
watched the
related to
musical
one, so,
or
yeah.
read the biography or history, US history. Okay, we don't have too much time to go. One last thing that I wanted to show you is the following. So we now went from the getcom file via Python to a CSV via the data importer into Neo4j Aura. But what you can also do is the following. If you're in your database here, then there's also an connect tab, and it shows you for the different languages how to connect to Neo4j Aura from those languages as such, right? And that's what I did in an example just this morning, actually before we started. I basically just changed or made a copy of the script that actually, let's see, I'll just put it in VS Code here as well. That basically uses the Neo4j Python driver to send the data directly to Neo4j, right? So meaning, I take the data from the getcom file again, but instead of outputting CSV, I basically turn this kind of CSV data into a map or dictionary. So I have first name, last name, birth year, gender, and so on, and the parents, have this all in a dictionary, and then I send this to Neo4j. So after I extracted all the data, I connect to Neo4j, open a write transaction, and then run my import statement with this data, with this whole list of data. So I create a list of these entries, basically. And then I get to back how many entries have been added in total. And you see the code is very similar. So we take our data row by row, we merge the person by ID, set the additional properties, and then connect to the mother and father in one go, and then we return the total count, right? And if you don't know mother or father, I'll put in unknown, and probably as a post-processing, I would delete all the unknown people and their relationships. So it's basically just clean up after the fact. But we can do this then only without conditionals and stuff like that. And so
Nice.
if I run this,
Very smooth.
so I basically just use environment variables to connect to Neo4j, Neo4j URI, Neo4j password. And if I go into my file here, I can export Neo4j URI is our connection URL. Export Neo4j password is our password that we have over here. And then if I run Python getcom to Neo4j and pass our precedence, or let's put in the royals into our database as well. So it added 3010 nodes for the royal family. And if we go back to our browser, Neo4j browser, we should have now more people in here. And we should also in Bloom, actually, if we clear the scene, we could actually Victoria.
I don't know if you need to refresh.
Or Hanover. Yeah, I think it should not need to refresh because it's just added data, but it only needs to refresh for the structure, basically. So what was in the file? Let's look at the file, Royal 92. So we had, yeah. Oh, we don't have name for the royals. We don't have the names yet, because that's something that we did in post-processing, right? So we could have done this directly when we add the data to the graph.
Yes, yeah, right.
But we have not done this. But what we could do now is actually go into our script and add it directly in our cipher here, right? So we could just say here set p dot name equals p dot last. First plus space plus p dot last. So I save this and run this again. And now our Victorians should be in there with their names as well, right? So if I go to Bloom again, what was it? Victoria Hannover, right?
Mm-hmm.
Okay. There we go.
There she is.
Right, and for the royals, we only have the parent relationships, so we should have all. Oh no, it also has sibling. That's interesting. Why does it also have sibling relationships? So perhaps I messed this up with. Oh, oh, that's a good point actually, because we merged them on ID, and they have the IDs are of course not unique globally, but they're only unique per file. So now I completely messed up the data.
And now we have royals that are relatives.
In the precedence.
Well, okay.
Let me clean this out real quick. Okay, now database is empty. We import this again, and it's a little bit embarrassing. But so mix the royals with the US presidents. They totally would love that. As such. So now expand relationships, and so there are some interesting things in here where there are some father relationships that shouldn't be there. So there's something weird going on.
Mm-hmm.
So we need to. Oh no, that's the unknown thing probably also. So I need to figure out to delete the unknown ones as well. Anyway, I just wanted to basically decode that you can use to connect to Neo4j directly with a driver here. Connect to Neo4j, create a session, and run this in a write transaction, and then you get your data inserted directly. You don't need to go through the CSV, but then you need to know basically how to do this. But this is also something that you could actually copy from the data importer. If you remember, in the data importer, we had in our results here the load query, and if you look at this is very similar.
Almost the same. Yeah.
It's almost the same, except it says node records instead of data, right? So that's basically what we passed in down here as parameter name. That's the only difference. And then you can actually copy this one by one. And then do your own operations or pre-processing, post-processing, and other things as well. Right. And I think that's about it, the things that I wanted to show today. And I hope you liked this and enjoyed putting family trees in. If you have your own family tree as a get.com file, or have someone else's family tree, or from your local community, then try it out and let us know if it worked.
Exactly.
Were there any other questions or anything, Alex?
No questions. No. StyDev Z had the suggestion with unwind while you were typing it, so I didn't interrupt your flow, okay. But we got around to that. So that was the only suggestion we had from chat today. Thank you for that. Like Michael said, if you tried this out yourselves and generated a nice Bloom visualization of your family tree, put this out on Twitter. Definitely would be tag us. Would be interested to see that. And with that, I think we're done for today. Thank you for watching. Thank you for joining. We'll be back next Monday. In the meantime, we have a couple of other sessions I'd like to quickly promote. Tomorrow, a new series going meta starts, where Jesus, a colleague, and I will discuss semantics, ontologies, knowledge graphs, and all that like. So I'm looking forward to that. So we start tomorrow with a
Really cool. You should watch that. If you're into RDF and linked data, then it's totally cool to watch Jesus do his magic.
yes,
it's really impressive.
Yeah. That will start tomorrow, so I'm looking forward to that. And on Wednesday, our colleague Florent is continuing his PHP and Neo4j series, so looking forward to that. So yeah,
super.
Let us know any suggestions, any feedback on Twitter, on Discord, anywhere else.
Yeah.
And with that, yeah, thank you for
you,
watching.
Alex.
Thank you,
Really
Michael.
enjoyed this. Take care.
This was
Bye-bye.
fun. Take